Nehal, I'm getting your audio. Can you be on mute? Hey, hi everyone. Good afternoon. Wonderful. Yep. Hi everyone. Good afternoon. So hope everyone is able to hear me. They're able to see the screen. Let us see on the social media. Yeah, so we have conducted so many sessions. Right, AI session was also right. AI session is scheduled. Industrial 4.0 session. We are the only EdTech partners, right, who is tied up with Panasonic. Panasonic has India Innovation Center, so we are the only organization which is connected with Panasonic. That's another USP that we have a cap on our feather. And yeah, quiz 5. Yeah, all these questions are getting accumulated. They will be very soon be populated here. Interview question section coming soon. And I'm assuming a lot of people have already downloaded the book. Not sure if you have done that. If you have not done it, you can download it from here and you can access the full version of the book here. All right. So subscribe to the social media channels, YouTube, Facebook, right? Our website, and on the website we have mind maps. These are very handy. Right, this is for data science. We will be covering few of the aspects of this data science and data pre-processing steps using R. Right, we will be looking into few packages. We will do hands-on on these things. All right, so we will be starting in a minute now. I still see a few people have to join in. We'll start in a minute, otherwise. Let me see how many people are there here. Okay, we'll begin otherwise. Okay, let's start. So R programming. Yeah, we are looking at R programming, and this is the interface. This interface is called as R Studio. This is the IDE, interactive environment, interactive development environment for the R programming language. And the R programming language is the functional oriented language, which is one of the easiest programming languages that we can learn. It's a high level programming language, which is like English, right? English language, English communication. So it become very easy for you to understand the coding. And this R programming was developed by two gentlemen. One of this person name is also gentleman, Ross Ihaka and Robert Gentleman. And they wanted a specific programming language for performing statistical analysis. Right, in New Zealand, University of Auckland, they started this programming language for doing statistical computing. It's a high-level, portable statistical programming language, right? And it has functional-oriented capabilities. The drawback of R is that it is a single-threaded software, right? These are the things that we have already covered, but I'm just revising things because it's been like 2 days in between, right? So people might have forgotten. So we have a command line interface to write the programs for R, right? And on top of this, we have RStudio, which is the interactive development environment, which is using a lot of additional graphical user interfaces or features to help programmers write the programs in a much easier and convenient way. And that's what you're seeing on the screen, RStudio. The first thing that you have to notice is the scripting page, where you're going to write your code and the extension. What is the extension of R programming or R programs? R program scripts. Right? They are stored as .r files. Right? They are stored as .r files. And these programs, though we are calling it as a script, they are interactive. That means we are executing the code line by line. You don't have to execute everything at one go, right? But if you want to execute everything in one go, there also we have options. Under this drop down, you can see the two options, source with echo and source. Oops. Yeah. Source and source with echo. Those are the two options that we have. Right? Next. It also has the environment tab, which basically shows the summary of the data that we have loaded. We have history, we have connections, we have tutorial. This is a new feature that's there in the new version of RStudio. We have files, plots, packages, documentation, and viewer. Documentation for R is provided for every small and big command, every big and small function. We have documentation available. And that documentation can be obtained by doing a question mark and the command name. We will be routed to this particular section. Then plots, or let's say packages. This is something that we discussed. Packages is nothing but collection of functions, right? Collection of functions. And there are a lot of functions that are developed, and these functions can be utilized as inbuilt functions by R, right? By other users. We'll come to packages again, but yeah, let's try and discuss in the flow. So this is a pane where you can manage your packages. Then plots is another pane where you get the visualizations, right? So today we'll try and understand the visualizations as well. Next, we started by looking at how we can execute the code here. We can select bunch of lines, or we can put the mouse cursor at any position of the line and then execute that particular line. So we press our run button, which would basically execute this part of the code. You can execute both the lines by selecting them, or you can also say only select certain part of that line and execute. So only selected part will get executed. This is how we execute the code in RStudio. Either you press run button or you can see control enter. These values that you are loading are atomic vectors, numbers, and R is developed for statistical calculations, right? So it understands the other data types also. So it basically deals with integers, it deals with double, it deals with character data, it deals with complex data, date, etc. These are the most important data types, fundamental data types that any programming language should understand. This, yes, of course, R will also understand. Next, when we talk about data, the data has to be loaded into memory. And in the memory, when you are loading the data, you have to refer to some name given to that memory location. This is called as a variable, right? And in R, we do not have to specify the data type. Based on what value you are assigning to a variable, the data type is automatically identified for that particular variable. You don't have to predefine it. It's dynamic from that perspective. You don't declare, you don't define, you just assign the values. And while you're assigning the values, you have to look at the assignment operator. Assignment operator. And in R, we can use either equal to symbol or arrow symbol. Arrow symbol is preferred in RStudio, in RProgramming. And head is always the variable, tail is always the value that you are assigning to the variable. And of course, equal to is also there. Then anything which is sequence, we can represent that using this colon symbol in R. Shortcuts, these are all different shortcuts that we have. Right? Next, we discussed about assignment operator. We discussed how to execute the code. Anything after hash is a comment. That's also something that we covered. You can see that. Right? For description purpose, we put that. Next, print is a command, a function, which will print anything which is represented inside that brackets. Right? So that's how we get the output, or we can also represent the value directly. So if I say x is equals to 1:50, it is capturing sequential values from 1 to 50. If I just say print of x, it will give the output, or you can also say x is printing the output. Next, we discussed about integer, flow, double, right? Anything under the quotation is character data. These are the fundamental data types. By default, R treats the data at the lowest granular level as vector, where vector can have only a single data type. It cannot have multiple data types. If you are having integer, then your data should have integer data type. It cannot have double. And in R, we represent this integer and double as integer and numeric. This is how it is representing the float values. Now, if you want the documentation, you can do a question mark. Right? Simply do question mark and you'll get the documentation. Let's see that. If I press print, then it is printing the whatever the data that is there. And then you say question mark of print, and you get the documentation here, right? So it says R documentation. Print is from the base package, and this is the documentation that we have. Few examples are also given. You might want to explore this if you have not done that yet. Next, we discussed about variable standards. We'll go back there. X is a variable that we have created, but this variable cannot start with a number. It cannot have special characters. Cannot have special characters. Right? It can be alphanumeric, but that numeric value has to be in between, not at the start. Anything starting with dot, except for dot and underscore, none of the special characters are allowed. And if your variable is starting with a dot, that means it's a hidden variable. Right? And the code, you can see, it is more like an English language that we have designed or learned. Then on the variables, the data types, we've also discussed about operators. And we discussed about arithmetic operators. And then we also discussed about assignment operators. Arithmetic operators and assignment operators. We have also learned logical operators. Right? That's and a dot. We've also discussed about relational operators or comparational operators. Right? We've also seen identity operator, that is percentile, n percentile. These are all miscellaneous operators that we have. Okay, additional operators that we can run. Right? And then we've looked at, after operators, we have also looked at the data types. And when we talk about data types, we have to start with vectors. That's the default data that we have. Then we created list. From vectors only we can create list. Here single data type, here you have multiple data types. Then we have matrices, and to get matrices you say matrix. And matrix is a two-dimensional data. And from the arithmetic operations we have seen, percentile star percentile will give you the matrix multiplication. Okay, so that's matrix addition or matrix multiplication can be done like this. Then we discussed about array. Array is greater than 2 dimensions in R, and here we'll mention the dimensions as an input argument for array. We basically pass rows, columns, and matrices. That's the 3 dimensions that we pass. Next, we've also discussed about if conditions, right? If else conditions, nested if conditions. Then we discussed about loops. In loops, we discussed about for loop, while loop. This is generally finite loop, and this is infinite loop.
Don't have to be recorded. हाँ अभी तो फिर नहीं कर सकते. हाँ, so it's showing me you are live. So who all are there? Only I am there. So can you guys join? Off कर.
Are built-in functions. Right? And these functions that we are talking about, the custom functions, they will have a specific syntax. Name, then use the keyword function and represents the bracket to arguments, and then open and close the brackets, flower brackets. This is going to define your custom function. Right? These are session specific, and these functions can be reused within the code. Once you define it, you can reuse the functions. We've also discussed about if else, for else, right? These conditions. So your conditions are being used to run the code in loops. Right? If true, then do a task. So that logic is applied into the loops also. We've also discussed the factor type. In our factor type is a special data type case, which is measuring the non-numeric data on numeric levels. We've also discussed, very importantly, the data frames. These are the default abstractions for your R programming, which is nothing but your table. But data frames will have fixed. That's the difference. Then from the functions, we have discussed packages. We call them as packages, or a package is nothing but collection of multiple functions could be there. So it's a collection of functions, collection of data sets, sample data sets, then documentation. So that people who want to refer to the functions which are provided in this particular package might want to understand what that package is doing. So certain documentation is also provided. And we have seen how do we install the packages. You simply say install dot packages and put the package name in double quote. This is gonna install the package into the system. Or we have also seen this IDE option, graphical user interface option, where you press this packages and it will list out all the packages details. Right? And then we have search button here, which will basically tell whether any package that we are trying to find out is installed already in our system or not. If it is already found, then probably you might want to upgrade it if the version is different, but otherwise, you're fine. Package is not available, not installed in the system, then you will be installing the package using using this update button. And if the package is not available, then use install button as well. Now this install button will initiate the same command, install.packages. Right, install.packages. Right. So that's about a few things that we have covered, right, in R programming. Now let us try and revise few things, and then we will try proceeding to understand how the packages can be actually used in analyzing your data, processing your data. Right. So first things, I have typed so many things, right? So many commands are there here, and it is really clumsy. I want to clean this. Control plus L will clean the console. Yeah, Control plus L will clean the console. That means it will erase the console space. But you can always see what is the previous code that you have run under History tab. Right? You might want to try any code. Let's say you're typing ls. Automatically it gets recorded here. See? So any command that we are trying to execute on our console is recorded. Right. So we have cleaned the console. Then we can also assign variable without any data. Remember, we were talking about automatically assigning the data type, right? So dynamic interpretation is there in R. That means it is automatically interpreting what is the data type based on the data that is getting assigned to the variable. Right? For example, here, if I say class of X, you can see it is an integer. Right? It's clearly showing that it is an integer. But we can also create X with null value. Don't need to have any variable data type. So you see, it is null. There is no data type here. It's empty. You can also assign values sequentially. We have already done that. And to access a specific value inside this, we say X of 3. Right? Next. If you want to assign different values, not a sequential values, different set of values, then by default, R is treating them as numeric values. Because we are giving access or we're giving provision to the users to have double values, right? Float values. So Y, this Y will become numeric. Now this is something that I've already explained. You're trying to type this arrow symbol and minus, right? So what you do, if you want to type in some number here, you might say A, then less than, put arrow, and then say 10. This is how you are basically typing in, but there is a shortcut. Alt minus. So you're going to put A and then say Alt minus. That will also give you the same arrow symbol. This is a shortcut. Then if you want to refer to this random number, any specific value, then you will say Y of 3. Y of 3, we get 8 here, right? That is the third position. So our index starts from 1. Okay, remember that. Then this arrow can also be used. This will create a variable Z and it takes those values. You can also have identity values. You can pass X to Z. So whatever values X carries will be there for Z. And we have also seen question mark. It's nothing but the documentation is shown. Question mark of C basically is combine values into a vector or a list. That's a C function. And then we have cat. We do question mark of cat. This is another function we have which will concatenate the content and then prints the content on the screen. If I have to do addition, this is a simple vector addition that we are doing. X plus Y, and you get summation like this. Point to point, we get summation. If I have a different length, right? You have different length here. X is only 5 objects. Now I can also do addition. What you're seeing is just a warning message. It's not error. It is only a warning message. X plus Z is this. So here the last value is getting printed in a round robin fashion. After the last value, the first value goes there. After that, second value goes there. After that, third value goes there. Fourth. So in a round robin fashion, we will include the more values here to get the arithmetic result. Computation. Right. Then the same thing is done for multiplication also. But here I'm multiplying with a constant number. So round robin is not the case. But if you want to multiply a vector with a vector, then we can do that. And you can see individual location, the points in that specific location are getting multiplied. Then list the objects, ls. This is going to list all the values there. Then we have XML as a package. We use that XML package to do a lot of things. And this package will include a lot of functionalities. Now we install the package using this syntax install.packages, and you have to always represent the package name in double quotes. For the install button, we do that. Okay. And for library function is to invoke the function, right? Invoke the functionality of the packages. So we will invoke. I'm not installing this again. Why? Because once you say install.packages, these packages are getting installed into the physical system, right? By getting that zip file from the centralized repository. So R is going to fetch the zip file, extract it, and place it in the specific downloads, documents folder. And in order to use this, in order to utilize this function, the libraries that we are loading, we have to invoke it. Now you can do a question mark of XML. Look at this, what happens. When I typed question mark of XML, I told you people that whenever you do XML question mark, I mean question function or basically a code or a package, it gives you documentation, right? But see here, what is it saying? Clearly it's saying that no documentation for XML. There's no documentation. And it also prompts, you could try double question mark of XML. There will be scenarios where the documentation is not stored along with the package. Now this XML is a very big package. It consists of so many things, and it is utilized in a lot of different functionalities. So documentation could be very huge. So when you do double question mark of that XML, it is searching. And look at that. It is searching for that particular XML in all the packages that we can fetch. Right? It's giving you the entire list. Now, based on what is that you're trying to achieve, you might want to choose this particular package. Right? Yeah. Next, update the packages is something that we have already done. We need to update the packages because there might be cases where the packages are getting updated. So we have these functionalities being developed by some people, and the core community is managing them. But still, it is just an open source, it is a research tree. So there might be some kind of updates to the code, right? In order to take the latest updates, we regularly keep updating the package. You can press that update button or reinstall your package. Update is just reinstalling the package. That's about your update. Right. Now let us try and understand some interesting aspects as part of packages or functionalities. So we have understood the basic foundation concepts of programming language are, right? All those things which are required for us to develop basically the code. Now let us try and how do you do manipulation of data in R? Now in order to do this, first things first, I'm trying to load the data set. Yep. So let's see. Okay, what is it saying? Cannot open the file because that file is not available. So let me scroll down here. Let me see if I can find the code. don't see that. All right. Let me see if I have the data. Okay, I have this dataset education.csv. Let's take this. I'm copying that file name. Yeah. And the path also is something that I have to copy. Such a big name, but yeah, let's copy it and paste it here. Oops. Yeah. So this is the dataset that I'm loading. I'm calling it as MBA. Let me load this. It will again throw error. /D is unrecognized escape in character string. So these are escape characters, right? We have /T, /N, /S, /I. These are all different parameters which are predefined to manage character data. Right? So when you put /D, it will not be able to understand what does that /D means, because it is interpreting the slash as special character or escape character. Right? So in short, R is not gonna identify the slash. It will not identify Windows path. You have to change this to /. So you're going to manually change this to /. Yeah. When you do execute this line now, look at that. There's no problem. The data has been loaded and I'm calling the data as MBA. Right? I'm assigning the data which is in CSV format loaded using read.csv into MBA. That's our dataset name. MBA is the dataset name. And yeah, this is what your dataset consists of. The summary is shown on the right side environment page. 773 observations of 3 variables. It's a summary. 773 observations basically means rows or records. Rows or records. 773 observations. And 3 variables, which basically means 3 columns or features or factors or attributes, whatever that you want to call it. This is the dimension of our data set. That means your data frame or data set will be of this dimension. You want to see the content, then you can click on this MBA name. Don't click on the blue icon, click on the name. And you see it is getting populated in the backend, in the console, view is getting executed. We say view of MBA. MBA is the dataset name. Capital V, mind you, it's not small v. If you type in view with small v, then the code will fail, saying function could not be identified. Because R is case sensitive. So I'm loading the dataset and I'm reading the dataset here. This is called as a viewer. You can pop this viewer out. And this is what you can see. Serial number, work experience, and GMAT. Yeah, we have in total 773 records. right? So this is your summary. That's your data basically. You can either type in view of the dataset name or just click here. That would basically give you the dataset name, but this is the code that is executing. Next. Yeah, next. If you try to pass Windows syntax, it is failing. So we decided that forward slash has to go, and that is the default syntax in Linux operating system. Yeah, this is slash that we see, right? This is Linux syntax. This is Windows syntax. Okay, so in R, it prefers forward slash, not backward slash. Either you give forward slash or you give double backward slash. Only then your R programming will understand the path. Right? We have already seen, if I try to execute this, it will basically have to pass, but let's see. Because of the data set location, it might fail. Yeah. And yeah, this is C/D is a skip character, right? It's not able to identify that. If I say this, it will do the calculation, no such file. So let me. So we have to update the path here and then put double slash. And we put this. Yeah, now it will execute. No such file or directory. Again, I have to see the path. Might have given wrong path here. The file name is education. Yeah. So I've loaded the data set and I'm calling it as XYZ. Both are same. It's just that you're loading the same data set using a different identifier. So in memory also it uses a different memory location and repeats the same data in memory. Right? And yeah, this is basically the syntax that we have to use. Either use forward slash or backward slashes. Now this code that we have executed, right, the read.csv, you might be saying that, hey, I'm a non-programmer, I don't want to use this. Can we have something like packages installation on a GUI screen? Yes, we do have. And that is this import dataset option. If you click on that, you see those options from text base R. Right? From text read R. From text base, from text read R. Then we have from Excel, from SPSS, from SAS, from Stata. So these are all different file formats. These are different file formats which R can easily understand directly. You don't need any modulations of your data and anything like that. Right? So we have from text coming from two different packages, base package and readr package. Yeah. Now if you try and execute this from base option, then you would get read.csv. You're getting read.csv. If I choose a readr option, then I would get read_csv. We have read.csv and we have read_csv. a slight difference between both the functions, but both of them are trying to read the CSV dataset into the system. Then if you have Excel, you can type from Excel, right? Or you can also use the other options if your data is coming from any of those sources. Right. In older versions, this option was not there. It was only there for from CSV, load Excel. Right. But later on, they've brought in a lot of other right libraries into RStudio. Right. Now, the dataset that you have loaded has a specific structure to it, definition to it. So in order to learn about the structure of the data, in order to learn the structure of the data, we can say STR. Now, we have univariate data here. That's what we will be learning first. We'll take one variable at a time and then try and understand how or what kind of analysis we can done. Right? This is called as univariate. Going forward, we'll also see two variables being analyzed together, that is bivariate analysis, or more than two, which is multivariate analysis. Okay, so if I say structure of the entire data set, it has multiple variables, right? So as soon as you click on this blue button, we see that it's showing you the summary. The same thing can also be achieved by typing structure of MBA. Same thing, if you click on the drop down button or this, type it. So it clearly shows that the database 77 data frame and the total number of records are 773 observations with 3 columns. Right? And the definitions of these columns is given. If you remember in the last week's class, I said the summary that we are trying to print will give 10 values, irrespective of the data size or the columns that we have. It is showing the first 10 rows of that particular column. So we have data serial number, then work experience, and then GMAT. GMAT is nothing but the GMAT scores. We have already seen the data set here. Now you want to know how many students have written the exam. That is very simple. You can also see that here in 773 observations. Right? And it has 3 columns, and each column that we are seeing is an integer. That is also clearly showcased in the function, str function. Right? So you might want to read the difference between read.csv and read_csv. Then we also have something called as write. Read is there, fine, but write is also there. Write function is used to load the content that you have created. Probably you're manipulating the data that you have loaded, and that manipulated data needs to be stored back. Right? In such cases, we go with write.csv or write_csv. Then we have edit function. Edit function is giving us this editor to edit the data values. Say for example, serial number 1 has work experience 720 as the score. Now I will change this. I will change the work experience to 21 to 100 and I'll close it. So the changes that we are making to the data center will now be stored in MBA1. So you can see that MBA has 21 here, whereas MBA1 has 100 here, because we have changed. Right? So like this, we can also dynamically change the values. Then we have get WD. This is another very important function. Get WD. Get WD is going to give you the current working directory. You can do a question mark and search for current working directory. Get or set working directory. Now what happens is, if you have a huge set of files that you are manipulating, a very big lengthy code, then you might want to optimize that by using this get your location. You can set that location using get with CWD. You have another function called set, so you'll be setting the directory as the parent directory or the main directory. You can also see here I'm setting desktop, right? So if you type in this, just say read.csv, MBA this dataset name, the dataset name that we are taking here, right? Let's execute that. I'll show you. Yeah, if I execute this, it is working. Why? Because your current working directory is the same where your file is located. I'll put it here. Now if you execute, it says no such file or directory. No such file or directory. But if you have that file in this specific location, then you will be able to get the result. So what R is doing is, it is first checking in that working directory, and if it is able to find the resource, it consumes it. But if that particular file is not present, then you have to search for it and assign the right path, full path of that file. That's what we have done here. We have set the complete path of the file. Only then it will be able to access the content and load it into the R memory. Now, once it is there in the R memory, you can do a lot of manipulations, right? So that's about loading the data set. If it is in CSV format, either you can try this read.csv, or we can also try read_CSV. Right? Both will help you load the data set into R memory, of course. And if you want to set a working directory, then you can set the working directory either by using setwd, or you can go here under tools. Yeah, under global options, you can set that working directory. You can also do here in the viewer. Fine. It's not loading. Okay, fine. In R also, we files also you have here. You can do set as working directory, or you can directly go to your working directory This is your physical access, right? Physical store access. So you'll basically be available for that particular code. The file will be available for that particular code that we are executing. This is the working directory home, and there it is there already. Right? Under session also we have set working directory option. So multiple ways where you can set your working directory, and in this directory you will be dumping all your required code and sub functions that you will be consuming at a later point of time. Right? So that is basically your reading the file logic. Of course, we will be looking into how to load JSON file, how to load XML file also. Right? It is very simple. You simply say, if it is let's say XML, a JSON file, you can say read.json. And if it is an XML file, then you are loading the dataset using XML function itself. Right? And you will say XML parser, basically. That's how you load the dataset. For JSON, we say read.json. Yeah, so that's how we load the dataset. We'll look into those things as and how we proceed. Right. So we have learned about loading the dataset using command line interface, and we've also learned how to load the dataset into R using this import dataset. Then we looked into editing option. We looked into the working directory option. We looked at how to set a working directory as well. Right? And we have also understood that the forward slash would work, not the backward slash. Or you do double slash. Right? Either you do single slash or double backward slash. Right. So that's about loading the dataset into R memory. Now there will be a lot of inbuilt memory datasets, guys. We will be discussing about that now. Okay, how to access this data, right? We have seen till edit. Then we will also now see the structure. We have already seen this. Now we will look into the inbuilt datasets, but before that, let's take a short break. In the meantime, let me take your questions. 1 second. So when will datasets? We have already started G1 just now. Now we already discussed that, Omkar. If you don't want to showcase your values, then you put the parameters and you'll put dot. For system variables, we generally use that. What's the use of working directory? Just now I told, right? If you have a huge set of data sets, what you do, you put generally everything in a specific location, one folder. And for R, you are declaring that is the working directory so that you don't have to type in these different locations. It's a centralized location where you put all the data points. What is it? Using a table. No, data frame is the default abstraction. Now, are you talking about table? I have not worked on table till now. I'm not sure what is table. Both are same, Mallikarjuna Rao, read.csv and read_csv. In older versions, we had only read.csv function. But yeah, I think in 2017, around that 2016 time, read_csv also was launched. This is exactly when, right, people were trying to look into Python as an alternative program for writing these machine learning algorithms. Right, yeah. Yeah, Omkar, you have too many questions. I think the basic questions you have to try and research. You could have Googled on understanding what is CSV. It's a file format. Oh God, okay. All right. So we will break now. Right before the break, yeah, just try and look into these social media platforms once again. Try and participate in the quiz that is being, right, captured here. Okay. This is day 5 quiz, which was launched on Friday. Today again we will have a new quiz, right? So every day we will have quiz. Make sure you are connecting here. Okay. Right. So very important. Again, I'm pressing on this. Having social media presence, digital presence is very important. So if you don't have accounts, create the accounts and connect. So it's 3:05 now. We'll connect back in 10 minutes. Okay, 10 minutes break. Yeah, friends. Yeah, connect back, guys. Please refresh and come connect back in 10 minutes. Hey guys, I hope you are back. Vishnu, yeah, we are planning on that. You might want to subscribe to the social media channels. There we will be uploading the code. You might want to take your code from there. And yeah, Rafik, sure. We'll inform the team from tomorrow onwards to do that. But the challenge is, right, a lot of people are just taking the attendance and leaving. It's for the namesake they give. So just making sure that they retain back by this. But yeah, we can do that. Okay. Sure. All right. Yeah. Yeah, please reconnect. You might want to reconnect here. Everyone else is able to hear me, right? Am I audible, friends? Can someone confirm? Yeah, I'll give that, Omkar. The tasks are coming your way. Not to worry. Okay, I'm audible. Okay, fine. Yeah. All right. So we looked at how we can load the standard format of a file. Majority of the times, the data that we are loading for statistical computing, right, will be in CSV format. This is comma separated values. Most of you people already know. That means each field in the data that you're seeing in a table representation like this, once it is loaded, is actually a data fields which are separated by comma. Wherever you see the comma delimiter, we consider that as a separate field. Right? So that's your comma separated values. And when you are loading, we use read.csv option to load the dataset. And you have to specify the complete path. Your R should learn or should be able to access the file that you want to load it into memory. So you have to give the path of the file along with the file name, of course, or put everything in a specific location directory and define the directory as working directory. Right? We basically call it as CWD or WD, working directory. To learn what is the current working directory, we can say get WD, or we can also set a specific folder like this as a working directory. You just have to use that set. From session we can do it, from files we can do it, right? So different options are there from where we can set the working directory. Okay, next. This is when you are trying to load a data set, which is an external data set. Either you say read.csv or you will say read_csv. For now, only look at this. We will discuss about this later. So we have read.csv to load the data. But remember, yesterday, the last class, we discussed about packages. And package is nothing but a collection of multiple functions, sample data sets. So data sets are there. And then documentation. So for documentation, you know, question mark is applied. Functions, you are installing the package and loading the functions using library to access the function names. But how about accessing the sample data? Right? So let us learn about these sample data in R. There's a huge list of sample data that is available. And you can look at the sample data just by typing data. The function is data. That's your inbuilt data set. I mean, list of data sets. Okay, it's not a single data set, but it gives you a list of data sets. When you execute, it will show an output here in the viewer, which basically talks about the list of our data sets. It is under a package called datasets. So in R, each package contains code, datasets, and documentation. But we have a package called datasets itself, and it lists out all the packages that we can access in R. Along with this datasets, other packages also give you datasets. So thereby you can see a huge list of datasets, right? So you can just scroll here. Once you set data, these are the datasets in package datasets. And for the package, the dataset name and the description, you can scroll down here in alphabetical order, or you can see the datasets are provided here in different, right, based on the package names and all that. Now you can also do this. All the datasets can be available here from all the packages. You can do this. Okay, just experiment. But yeah, this dataset itself is a very big dataset. Huge list of packages. The sample data is available. Now, how would you know what is the dataset? What dataset you are dealing with? What content does it has? Right? In order to understand this, we will say, let's randomly take chick weight. To understand this, you can see weight versus age of chicks on different diet, right? So these chicks are fed with different diets, and we are recording their growths. A sample data set, mind you, this is a sample data set, right? So how do I call the data? How do I actually access the data set? Now the beauty of R, this is a simple description, right? You want to learn more about the data set, you can simply say question mark of chick weight. So there are two different data sets here, chick weights and chick weight. An experiment was conducted to measure and compare the effectiveness of various feed supplements on the growth rate of chickens. This is the chicken weight, chick weight data frame. It contains 578 rows and 4 columns, right? So like this, you have sticky note, which basically gives you the immediate description. You might want to select the data set that you want to read further. When you click this, you can see our documentation is open. This is the data set name, and this is the package name. Weight versus age of chicks on different diets. That's the heading that you're seeing here. But you can see a lot of details when you deep dive into this particular documentation. Right? Now, how do I access this? I want to access the data. So all you do is data, and within this brackets, you are going to select that particular data set. Right? You can just start typing, it will automatically prompt you the name. You can select it. When you do this, there is a connection established. Here you can see it says promise. So as soon as you execute this, R is trying to create a connect to load the data set. It's not yet loaded it, it's just creating a connection. You can say this is a connection like that. And when you click on that, you are basically typing a command called view. That means you're trying to access that data. So you're saying force chick weight. Force means you are basically loading the data set. Right? Let me erase this entire data. Right? And let me load. 1 second, the data set here. Yeah, I'll have only this, and then we will load the chick weight data. So let me type in data of chick weight. Okay. You can see it says promise. Unevaluated promise, that means there's an establishment, connection establishment, which is getting done. Right? Now, if you try to access or if you try to view this data, then immediately you don't even have to type it completely. The data is completely loaded now. That means it is going, because you're trying to access that data set, the data set is being loaded into your memory, and yeah, this is what you are going to see. And if you say view, it is showing you the data set. You have you have weight, time, chick, and diet. Right? So you have different chicks, 50 different chicks are taken, different diet programs are given, and we are trying to look into this data set. You can take any data set. Let's say I take orange here. Randomly I'm choosing this, okay? Data of orange, it says promise, and now I'll say view of orange. Tree age and circumference. Orange trees are being analyzed. You might want to learn more about it. You're going to type orange like this. Growth of orange trees. 35 rows, 3 columns. Right, and this is the data set. It has age, circumference, tree. The definition of these things are given, and further details are provided. You can also do this. You can also try and execute these commands for practice purpose. Right, so these are the inbuilt data sets that you can work on. Right? So you can also say pressure. When you say view, it is going to show you the data set. Right? When you say question mark, it will basically give you the documentation. We have a data set called Titanic. Now, not every data that you are going to load will be in a data set, data frame format. That is also something you have to understand. Not all the data sets are in pure data frame format. Let me close these things. Right? I have this data set called Titanic in the list. This is the Titanic data set. Very popular data set, not just because of the movie, but because of the incident that it has, right? The Titanic incident that occurred. Now, if I say data of Titanic, it is loading. I'll say view. What you're seeing here is a data set in a table representation, okay? But if you observe Titanic here, it says table and it gives you array representation. Right? It says 1:4, 1:2, 1:2, so on and so forth. It is not a data frame. It is not showing the data as 1, 2, 3, 4, 5, 32 by 5 representation, right? So this is something that you have to look at. Not all the data sets that you are loading will be in a proper data frame format. They may be in different formats. Okay, this is Titanic. It is in array format. You can say array format. If you do question mark of Titanic, you'll get the details. Survival of passengers on Titanic. This data set provides information on the fate of the passengers on the fatal maiden voyage of the ocean liner Titanic. Format, it's a 4-dimensional array. It's not a data frame. cross-tabulating 2,201 observations on 4 variables. Those 4 variables are the class, the sex of that passengers, age, and survived. Right? Whether the passenger was survived or not. So that is your a 4-dimensional array, which is represented like this. Right? Now you can read the data and all that, but applying a lot of functionalities on this particular table array format may not be possible in R. Okay, like when we do the statistical calculations probably tomorrow, right? When we see this, you will get to know that not all the transactions can be directly applied onto this particular array format data. It has to be in data frame format. So if you need to convert this data, which is in array format, into a data frame format, then very easy, you say as a dot. This is called as typecasting. Using as a dot, we can change the data type. Right? All these are different formats that we can apply. Now we want the data in a simple data frame format. What is the data? This is the data. Now let's say I'm calling it as Titanic _ data frame. So I'm loading this array. I'm not changing the array. I'm having the array data as is, but I'm creating that array into a data frame format and loading it into a different variable. You can see here, this is the data set, Titanic data frame. It has 32 observations, 5 columns, whereas Titanic is an array. Right? The first one is the class. It has 4 categories. That's what it says. Table num 1:4. Then the second one is the gender, the sex of the passenger. Then the age of the passenger and the status, whether they survived or not. 2 categories. Right? So this is your data set. You're simply converting that into a data frame, which basically gives us 32 observations and 5 columns. It looks very similar. What you're seeing here is same. But internally, R should understand the data in rows and column format. Right? That's the default data type. Now you also have different data types. For example, air passengers, the first one you see. I'll say question mark of air passengers. Now, if you see here, it says monthly airline passenger number from the year 1949 to 1960. Passengers data. Right? It is time series data in terms of thousands. It is not a data frame. Okay, it is not in a data frame. It is in time series format. Now let me see this data. I'll say data of air passengers. We are loading it, and I'll say view of air passengers. And look at this. The format is time series. Time series is, as the name suggests, it's a series of data with respect to time. From the definition here, it says monthly airline passengers. So you can imagine this is Jan 1949 month data. Number of passengers who have used airlines for their commuting. So on and so forth, you have the data in sequence. So this becomes Feb. This becomes March. This becomes April. So sequential data, because monthly, it has to take 1 month at a time in sequence. That's called as time series data. Right? So this is called as time series data. Right. So that is about the list of datasets in R. Now remember, it is not just the package datasets. Okay, any package that you try to load, right? It has datasets in it. So let me try to load a package here. Okay, A rules. This is a package that I'm loading. We have recently updated it, right? So we'll load this. Yeah, I've loaded. Library function is executed. Now we will again do data. Now if you see, it says datasets in package A rules. First A rules is coming and then datasets is coming. In alphabetical order, the packages details are printed here. So in A rules, we have again a different set of datasets. Completely different set of datasets here. Right? So this way, we basically have a huge repository of datasets for your practice. Right. Yeah. Now, the structure. As I said, as a dot is a function, is a command which is used to change the data type. So we have used from array, we have converted the data into a data frame using as dot data frame. We also have is function, is dot function here, which is basically identifying what is the data type. It is confirming whether the data type is numeric or not in this case. So the output of is dot function will be a Boolean function, either true or false. So here we are saying A is red, some random color, a string data, I'm adding a string data. And if it's a structure of A, it says character data and the value is red. It's a text data, right? So it is a character data. Now you want to convert that into numeric. Is it numeric? No, it is not numeric. But if you say is numeric, what will you get? You're getting a warning message. Because obviously your non-numeric data cannot be converted into numeric data, right? As dot function is there, but it doesn't mean that you change as you wish. Right? Now if you say structure of B, it says number numeric, but there is no value there. B doesn't store any value because A is not a numeric value. Right? NA value will be there here. So that's how it handles. R handles these requests by throwing warning messages and showing that NA field is there. But yeah, certain things we can always do. Array to a data frame, we can always convert the array, multi-dimensional data, into a two-dimensional data by segregating the data. Right? And structure, we have already seen, it's a data frame. Okay, underscore df. Yeah, you can see it's a data frame. Right? And the data that you will see here is a categorical data, right? It's categorical data. If you say structure of Titanic, everything is shown as numeric. Let me show you that. STR of Titanic. So it's a table data and the numeric values are there here. for the dimension, and the values of each of these category are character data. Right? Each of that is character only. But when you converted this into a data frame, it created those dimensions, 32 observations with 5 columns. But look at that data type. Class is now becoming a factor. Remember we discussed about factor? Factor is a data type, a special type of data type in R, which is treating the non-numeric data on a numeric ordered scale. It puts those things in levels. By default, it will be ordered based on either alphabetical order or the numeric representation that the data has. So here you have first, second, third, and crew, right? So numeric values are there, 1, 2, 3. So thereby you get that sequence here, 1, 2, 3, 4. 4 is crew. Then we have the sex of that passenger, which could be either male or female, and we are putting this. Male and female are added like this. Right, 2 levels. We are treating male as 1, female as 2. By default, you need to understand, by default, these factors actually take the values as based on alphabetical order. So that means female should have been 1, male should have been 2. Right, but because we are treating that inbuilt data set, it is automatically converting that into 1 and 2, male as 1, female as 2. Then we have age, child and adults. Here also child is being treated as 1, adults as 2. Then finally we have survived. If you see survived is no and yes again, right? So no is 1, survived yes is 2. Those are the 2 levels that we have. But the last column, frequency, in each of that segment, how many people have survived? So here you see, third class, male, 35 people have survived. No, not survived, sorry. Frequency, not survived. 35 members. In that segment, 35 people have not survived. Right, if you scroll down, probably here you have S, and you can see 13 people have survived. Male child, 13 people have survived. So yeah, this is basically how you can identify your data by converting the data into different data types. So here we have is, this is to verify, as is to convert. Next, whenever we want to try and do analysis on the data set, we will have to try and do certain calculations. Right? We have to do certain calculations. These calculations are called as statistical calculations. There will be a lot of statistical calculations. We will also have to try and visualize the data in graphical form. Remember, R is specifically developed for doing statistical computing. Right? So before we proceed to perform statistical computing, you'll need to understand why these calculations are required and what all the kind of interpretations we can make by doing these calculations. In statistics, in data science stream, analytics stream, we have to start looking at calculations which can be classified as the first moment, second moment, third moment, and fourth moment. Together, These calculations will let us know a lot of details about data. This is called as EDA. This calculations that we are doing is called as EDA, which means exploratory or elementary. Exploratory or elementary data analysis. DA is data analysis. And this is the first calculations that you will be doing on given data. Before you actually proceed further to develop any data science related solution by analyzing the data, the first thing is understand the data, right? So these are your EDA concepts. So these are your EDA concepts. First movement, second movement, third movement, fourth movement, and then you'll also have to visualize the data. This would basically help us understand the data better. And as and how you are basically trying to do this, you'll also try and understand the challenges with respect to the data. Or vice versa, when you're trying to look into the data for further statistical calculations, you will see that there will be challenges, right? So that is basically your data cleansing tasks. So once you have data, you'll have to prepare your data for further analysis. So all these things are something that you have to understand, and we will be learning about these concepts, and we'll understand in R how we do, right, achieve these things, where these things are used, and how we can basically take the advantage of these concepts. Together we call them as data understanding steps. So data is obtained, right? We have inbuilt datasets, we have datasets available by external sources. We load that into R, and from there on, the processing of your data starts. We have already studied, we have just now looked at typecasting. Typecasting basically means converting one type of data to another type. We have just seen that an array was converted into a data frame, because data frame is the default abstraction of the data for R, and if your data is not in data frame format, then you will not be able to achieve a lot of computation on that. So you might want to convert the data into this format first, and that's exactly what we have done. This is called as typecasting. Not just this, you probably have integer, you might want to convert that into character. You have a vector, you might want to convert that into a list, or a list into a matrix, right, or a data frame. So these kind of conversions is called as typecasting, and in order to do that, we use as dot function. To verify, remember again, to verify what is the data type, we use is dot the data type name. Then we say as dot to convert, right? So typecasting. Then we will try and understand what if you have extreme values, what you do, what you have to do if you have missing values. What does transformation means? Why does you require transformations? Then what does discretization means? Why you require this? So we will take certain examples. We'll try to do all these things, right? We'll start tomorrow with this. And as and how the situation arises, we will try to address these preparation steps as well. So today we have looked at typecasting. Tomorrow we will see outlier and missing values. Probably based on the time, we will also look at these other formats or the things as well. Right. Let me look into your questions today. Yeah. Yes, that's correct, Narsimha. Typecasting is a generic word. Yeah. Attendance link is there, Samruti. It's there on the sticky note. You might want to take that. Okay, wonderful. Yeah, V is uppercase. That is specifically I mentioned, right? It is V is uppercase. R is case sensitive, friends. Remember that. You will be notified about that, Srinu. Not to worry. You'll be notified about the classes. Anyways, I think the phone number is shared with you. You might want to connect and get the details. Okay, Chandrasekhar. Hope you have got the gist of the things that we discussed today. Okay. So today, predominantly, we have seen how to load the data set using the command line interface, which is read.csv. Or we can also use the graphical interface here, which says import dataset, using this from text base. From text base is read.csv function. Right? Both will be same, but yeah, from text will be a graphical interface. When you click on it, you'll get a pop-up. There are various ways. We have not did not discuss that. We are only looking at command line interface now. We'll compare all these options, right, one go when we have, right, when we come to that particular area. So read.csv is the first thing that we did. Loaded a data set which is provided to us. And we've also seen the current working directory. And we've also understood how this current working directory will be helpful. And how we can set a working directory. Then we have looked at accessing the data. There's a lot of inbuilt data sets that are available. We are using data, open and close bracket, to access that particular list of data sets. And every particular right package also has data sets. Almost all the packages have data sets. Very rarely you'll have data sets, packages which do not have data sets. But yeah, almost all, 99% of the data sets will have it. So we have seen the list of datasets package itself, and we try to load the dataset by using data and the dataset name. You do question mark, it will tell us about the documentation of the dataset, the features, the fields, etc. And then we understood the format of the dataset. And if you want to convert, you use as dot function. This is typecasting. Right, this is what we have covered today. And we've also learned about the syntax which needs to be used to load the data. You cannot use Windows format. This cannot be used. The backward slash cannot be used. You have to use either forward slash or double backward slash in order to access your data set from your system. Then we have also revised the concepts of packages, right, and ls functions, right. All these things we have already covered and we revised it today. So data sets, very, very important. Just explore your data sets, and there are a lot of calculations that we will be doing on these data sets, friends. So we are somewhere here. So much things have to be discussed. We're just starting into data analysis now. Right. Any questions, friends? Yeah, don't miss the sessions, because we are now jumping into data analysis. Each topic is very, very, very important. Rohit, it is there on the sticky note on the chat window. You can see at the top, there will be a link, that is attendance link. You can look into the graphical interface, Anand. You can see here, this is the list of packages you already have. Right? All these are the list of packages which you already have installed in your system. Right? These are already there. Very easy to access the list of packages there. Yeah, if you're talking about a command to show the list of packages, then you can simply say library. We have learned how to load the data set, right? So if you just say library function here, that will list out all the packages that are installed in your system. This is your default location in the documents folder, and these are all the files, the packages which you have installed. Either look at here or type library, that's going to give you the list of packages. Why you want to learn any notes, Venkatasai? Everything is there here in question mark in the documentation. You don't need to invest anything on notes. Everything is there in RStudio itself. I didn't understand, Sukanya. What do you mean by link of data science class? You might want to connect to the contact details that you are in touch with. All right, any more questions, anyone? Okay, I'm assuming no questions. So please participate in this quiz. This is another way to revise the concepts. Very, very important. Don't ignore this. Because only 55 comments, 14 likes. That means you are not participating in the quiz at all. No. How would I know whether you have learned or not? Right? I'm assuming that you did not learn anything from the previous last week class, 1 week class. And I'll assume that all my efforts are gone wasted. Don't do that for me. Right? Please participate in these quizzes, guys. It's a fun way. 5 minutes. It will not take more than 5 minutes for you. Participate. Is time series a data type? Yeah, it is a form of data. Yes. All right. So with that, let me conclude the day. Okay. Attendance link is already shared, right? Okay, friends. Thank you so much. Attendance link is shared again. Please fill your attendance and do provide your feedback as well. The same link has the feedback also. Please provide your feedback as well. All right. And request not to miss the session tomorrow. All right. Thank you, guys. Thank you so much. And let's connect tomorrow.